Bridges are more than just paths connecting two distant points across dangerous or deep waters. They represent the peak of human engineering and our desire to conquer nature's biggest obstacles. Every structure tells a story of innovation and the constant pursuit of the perfect balance. Imagine a world where we could never cross a wide river or a deep canyon. Since ancient times, humans have built walkways to bridge the gaps in our changing world. From simple fallen logs to complex steel networks, the evolution has been truly incredible today. Today, we look at these giants and wonder how they actually stand so incredibly strong. The secret lies in the delicate dance between physics and the materials we carefully choose. Gravity is always pulling down, but engineering pushes back with an even greater vertical force. Let us explore the fundamental principles that keep these massive structures high in the air. Every bridge must handle two primary forces, known as compression, and also intense lateral tension. Compression pushes down on the bridge, while tension stretches the materials to their absolute limit. Balancing these forces is the primary challenge for every engineer designing a new massive project. Beam bridges are the simplest form, using horizontal beams supported by vertical piers deep below. They work well for short distances, but struggle when the span becomes way too long. To cross wider gaps, engineers often turn to the elegant strength of the classic arch. Arches work by redirecting the weight into the solid ground at either end of bridge. This curved shape is incredibly efficient at handling heavy loads without any middle supports needed. For the longest crossings imaginable, the suspension bridge is the champion of the open sky. These structures use massive cables to hang the roadway from tall towers standing high above. The cables carry the weight of the cars and the bridge to the strong anchors. Cable-stayed bridges look similar, but work differently by connecting cables directly to the main towers. They create a fan-like pattern that is both beautiful and structurally very sound indeed today. Choosing the right materials is just as important as the design of the actual structure. Steel provides incredible strength under tension, allowing for much longer and thinner bridge spans overall. Concrete is excellent for compression, making it perfect for the pillars and the deep foundations. Modern engineers often combine both materials to get the best benefits of each material type. Before construction begins, surveyors must analyze the ground deep beneath the moving surface water. Foundations must reach solid rock or stable soil to prevent the bridge from slowly sinking. Building underwater requires specialized techniques like using massive cofferdams to keep all water out. Workers build inside these dry chambers, deep below the surface of the rushing river water. Once the foundations are secure, the towers begin to rise high above the blue waves. This is often the most dangerous and visually impressive part of the entire building process. For suspension bridges, the spinning of the main cables is a feat of extreme precision. Thinner wires are bundled together until they form a cable thicker than a grown person. The road deck is then lifted in sections and attached to the hanging steel cables. Wind is one of the most powerful enemies that a long bridge must always face. Aerodynamics play a vital role in preventing the bridge from swaying or collapsing completely today. Some bridges feature open gaps in the deck to let the wind pass safely through. Others use heavy weights called tuned mass dampers to absorb the dangerous and strong vibrations. Temperature changes also cause materials to expand and contract throughout the different weather seasons. Expansion joints allow the bridge to move slightly without cracking the hard road surface above. Bridges must also withstand the constant impact of heavy traffic every single day of year. Thousands of vehicles crossing every hour create a daily load that engineers must carefully calculate. Maintenance is a never-ending task to ensure the safety of everyone who crosses over safely. Rust and corrosion can weaken the steel structure over many decades of very harsh weather. Painting and inspecting every bolt is necessary to prevent any potential structural failures in time. Bridges are not just functional. They are often works of art that define city skylines. Lighting design can transform a bridge into a glowing masterpiece during the dark night hours. Many cities are recognized specifically by the unique silhouette of their most famous bridge structure. Pedestrian bridges allow people to walk safely across busy highways or scenic natural park areas. These smaller structures often push the boundaries of creative design and modern artistic aesthetics. Floating bridges are used when the water is too deep for traditional fixed bridge pillars. They rely on large pontoons to stay afloat while carrying heavy vehicle traffic across water. Movable bridges can open up to let tall ships pass through the waterway directly below. These complex machines require massive gears and engines to lift the heavy road decks up. The bascule bridge is a common type that tilts upward using a large, heavy counterweight. Swing bridges rotate horizontally on a central pier to clear the path for large ships. Vertical lift bridges move straight up like an elevator between two tall support towers above. Every type of bridge solves a specific geographic problem using a clever engineering solution today. The history of bridges reflects the history of human progress and our collective technological growth. We have gone from simple rope bridges to massive structures that span many, many miles. Earthquake zones require bridges that can flex and move without breaking into many small pieces. Base isolators act like shock absorbers to protect the bridge from the shaking ground movements. Innovation continues as we develop new materials, like carbon fiber for even lighter bridge designs. Smart sensors now monitor bridges in real time to detect any tiny cracks or unusual movements. This data helps engineers perform maintenance before a small problem becomes a major disaster situation. The environmental impact of building a bridge is also a major consideration for us today. We must protect the local wildlife and the quality of the water during bridge construction. Bridges can even include green spaces and parks to provide nature for the local citizens. Some of the highest bridges in the world sit thousands of feet above deep canyons. Looking down from these heights is a breathtaking experience for any brave traveler or tourist. The sheer scale of these projects is almost impossible to fully grasp from far afar. It takes thousands of workers and years of planning to complete one single massive bridge. Computers now help design bridges that are more efficient and use much less construction material. 3D printing technology is starting to be used to create entire small bridge structures today. This could revolutionize how we build infrastructure in remote or very hard-to-reach places. Even with all our technology, the basic laws of physics stay exactly the same forever. A bridge is only as strong as its weakest point or its lowest deep foundation. We must respect the power of nature while we try to build across it safely. Every bridge is a monument to human curiosity and our power to solve hard problems. They bring communities together and allow for the exchange of goods and new innovative ideas. Without them, the modern world...